Homework 1.6, other types of equations, video 4, homework due Saturday, May 16th, 2020 at 11:59 p.m. If you're comparing the beginning of this video with the end of the previous one, I accidentally erased this list and then wrote it again. The wording is consistent. I don't know if it's exactly the same, but our second step, didn't know the first one yet, was to square both sides of the equation and then finish solving and then check for extraneous solutions. So what's different between this example in part 2 versus the previous one? We'll take a look and see if you can figure it out. Structurally, this equation is almost the same as the other one, with one big difference. Do you see it? This guy. There's something outside the square root. Could we square both sides right now? Well, technically we could. But to square the left side would set up a gigantic FOIL problem, because this guy is essentially a binomial, that minus that. And I don't know about you, but if I can avoid doing a FOIL problem that has a square root as one of its pieces, I will. There are actually some problems where you can't avoid it, but we don't have any of those in our homework. So, what should we do? Square both sides? Nope. Move number 1. If necessary, isolate the square root. If necessary, isolate the square root. And this is actually a fairly standard move for lots of equation solving protocols. You want to isolate something so that you can get rid of it. Earlier it was isolate the squared part. Here it's isolate the square root. In a moment it's going to be isolate something else. But anytime you're trying to get rid of something like a chunky square root, you want to get it by itself first. So how would we isolate the square root? By getting rid of the thing that's preventing it from being by itself. We need to get rid of the minus 9. So what should we do to the minus 9 to make it disappear? Well, since it's subtracted, we could add it to both sides. If I add 9 to the left, the 9's will cancel. If I add 9 to the right, there's no like term to combine it with, so I can only write x plus 9. And now the square root is isolated, and now we can square both sides. Square root of 2x plus 26 squared equals x plus 9 squared. And remember, the purpose of the squaring move is to cancel the square root. So we're left with 2x plus 26 on the left. But what do we have on the right? Answer, a FOIL problem. If you are looking at this and thinking, let me square both pieces, stop. There is no distributive property that says you can distribute a power across a plus. You know, now's the time for me to say something I meant to say earlier. There are times when you can distribute things and when you can't. Like everybody knows that you can distribute 5 across x plus 3 and get 5x plus 15. And in previous videos I said if you square something like a fraction, you can just distribute the square and square both sides of it. But right now I'm saying, but don't distribute here. So how are you supposed to know when you can and when you can't distribute? Well, you can memorize all the rules, or I can show you one picture that will almost always take care of it. Almost. In a previous video, I showed you the order of operations as a total whole. And I also mentioned that square roots are kind of on the same line of exponents. One way to think about when you can distribute is you can distribute one thing across the thing below it. I can distribute exponents across multiplication and division. I can distribute square roots across multiplication and division. I can distribute multiplication across addition and subtraction. And you can distribute division across addition and subtraction as long as you're distributing across a denominator. Like when we had something like 6 plus 2 squared root of 3 over 2, that's really 6 plus 2 squared root of 3 divided by 2. Division only distributes to the right side. But in general, you can only distribute one level across the one below it, which means you cannot distribute from here to here. That's bad. You cannot distribute exponents or square roots across addition and subtraction. So that's kind of the big picture about the distributive laws. You can only distribute from one level of the order of operations across the one below it. But I digress. If we're going to square x plus 9, we have to write it twice and FOIL it. So I'm going to spare you the FOIL details, and you will get x squared plus 18x plus 81 once you've combined like terms. All right, so we've just done step 2, which is square both sides, and lo and behold, it's another quadratic equation. So now we have to shift gears while we're finishing solving and treat this like a quadratic equation, which means I'll need to get it equal to 0. Now, because this has like terms all over the place, here's some x's, here's some constants, I think I'm actually going to write the steps that you would do. Subtract 2x from both sides, because it's not just moving over, it's moving over and combining. So I really don't want to increase the chance of me messing something up. Subtract 26 from both sides. The x squared is still that. 18x minus 2x is positive 16x. 18 minus 26 is positive. See, 11 minus 6 is 5. I have to borrow 1 from the 8 and make it a 7. 7 minus 2 is 5. And we get x squared plus 16x plus 55. And you are more than welcome to bring out the quadratic formula. Now, while you're getting it set up, I'm going to look at this and go, well, do I know two numbers that multiply to give 55 and add to give 16? Well, I only know 2 pairs of numbers that multiply to give 55. 1 times 55 and 5 times 11, which is good because 5 plus 11 is 16. And if we solve each factor equal to 0, we get negative 5 and we get negative 11. But we're not out of the woods yet. Remember, the last step in solving a square root equation is to check for extraneous solutions. So I do have to substitute each of these values and see which ones are good. And by the way, I have seen problems like this where both answers are good. I've seen problems where both answers are bad and it had no solution. And like the previous one, I've seen problems where one answer is good and one answer is bad. So you can't just assume that this one's good so that one's bad, or you can't assume anything. You actually have to check them all. So let's check the first one. X equals negative 5. By going back to the original equation and substituting each x with a negative 5. So 2 times negative 5 plus 26 is under the square root minus 9. And we're asking, is that equal to x, which in this instance is negative 5. So nothing to do on the right side, so we'll just bring down the negative 5. And now let's work out the left. Haven't done the minus 9 or the square root yet, or the plus 26. We start by multiplying. 2 times negative 5 is negative 10. And now combine the numbers under the square root. Negative 10 and 26 is 16. Still haven't square rooted. Still haven't subtracted the 9. Square root of 16 is 4. 4 minus 9 is negative 5. Hey, the negative 5 worked. We'll put a box around it and check it. But now we got to check the negative 11. So let's see how much of this I can salvage. I can salvage the square root of the minus 9 and the 26 and the 2. Now in practice, you should just write it over again, but I'm trying to not erase it all. All right, so let's check x equals negative 11. You know what, since you're probably writing this down, you should be writing this down since you can use your notes on your test. I'll just start it from scratch. All right. So square root of 2 times negative 11 plus 26 minus 9 equals, or we're asking is it equal to x, which is negative 11. Nothing to do on the right side, so the negative 11 is there. But on the left side, under the square root, 2 times negative 11 is negative 22. And then under the square root plus 26, negative 22 plus 26 is 4. The square root of 4 is 2. 2 minus 9 is negative 7. No, it isn't. Well, 2 minus 9 is negative 7, but that is not equal to negative 11. So negative 11 is an extraneous solution, and the only solution is negative 5. One last comment. Here's why the negative 11 stuck in. Ignoring the negative 9, this ended up being 2. So ignore the negative 9, okay? This ended up being 2. This ended up being 2. What do you get when you put negative 11 here? Negative 11 plus 9 is negative 2. 2 is not equal to negative 2 until you square both sides. So squaring both sides can inject extraneous solutions, which is why we have to check them. All right, so at this point, you should go into the homework and try questions 5 through 9. So try homework 1.6, numbers 5, 6, 7, and 8. I'm sorry, I said 5 through 9, it's just 5 through 8.